9.4, solving quadratic equations by using the quadratic formula. That's what you're looking at right here. Go ahead and grab a piece of scrap paper, and I want you to write this at least a couple times and say it to yourself as you do. When I was in algebra, we were made to memorize this by heart, and you actually get pretty rhythmic, like in a pattern as you say this. But like the same deal, if A is not 0, if A does not equal 0, then anything that you see that's a quadratic equation that's in this form, so just like usually, it has to be set equal to 0, you can find any of those solutions using the quadratic formula. And you might say, well, what's the point? Well, sometimes methods like factoring are going to fail you, and so you're dead stuck using what is known as the quadratic formula. It's kind of like the last resort. As you write this, I want you to write x is equal to on scrap paper, and then say this to yourself. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I can spit that out pretty easily because I've done this so many times. So it's like you're saying negative b plus or minus the square root of b squared minus 4ac all over, meaning it's a fraction where everything is over 2a. On that scrap paper, don't do this quickly. Do this a couple times neatly. Negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Get to where you can be like, x is equal to, well actually you don't even have to say that as long as you know where it's from, but from memory, maybe put this on the back of a flashcard and just be able to say negative b plus or minus the square root of b squared minus 4ac all over 2a. That's how you want to be with this. And if you're interested, we can prove this using completing the square. So if you're curious to see where the formula comes from, grab me. And if you're feeling comfortable with completing the square, you'll see where those actual values come from. So solve each equation, round to the nearest tenth if necessary. And pay attention here, nearest tenth. This one actually you could factor. So to help us organize this, go ahead and on this left side of the page, factor this to solve for your solutions. Pause it. I'm going to jump to a new slide where I've already completed that part right about now. So here, if you can factor it nicely, you wouldn't bother with the quadratic formula. Every single time you do one of these problems, get your formula set up. So negative b plus or minus the square root of b squared minus 4ac over 2a. You can give yourself little miniature quizzes like this. Have the flashcard face down, see if you can write it out, flip the flashcard, compare it, see if you make any mistakes. So there's two reasons really why you do this. If you rewrite it, it's another round of practicing the formula. And second, if you rewrite it, you can kind of map the values for each one and keep everything in the correct order. This formula needs us to pull out what the values of A, B, and C are. And everything's always in standard form, so there's my A is 1. B is not 2, it is negative 2. And then C is not 24, it is negative 24. And that really matters as we're placing these values into the formula. When I go in to substitute these values in, I can just bring my equal sign down. I don't need to rewrite x because it's implied. And for these earlier ones, I'm not going to jump into showing that this negative 2 is positive 2. I'm going to show the minus sign, and then in parentheses, I'm going to write negative 2 for clarity for our notes. Moving to the second part of this equation, we get plus or minus the square root of b squared, again, in parentheses. Depending on whether or not the exponent's positive, it may or may not matter. Depending on whether or not an exponent is odd or even, it may not matter. But by putting the negative inside the parentheses, we really prevent errors. Minus 4 times A times C, which is negative 24. And all of that is going to be over 2A. I rewrote that to try to make things stand out more nicely. I'll bring an equal sign down. Negative negative 2 becomes positive. Plus or minus stays there. The square root of 4, and since this 24 is negative, I'm going to end up getting a positive 4 times 24, which is 96. And then 2 times 1 is just 2. Which is equal to 2 plus or minus the square root of 100. Maybe you're making a connection and realizing, well, the square root of 100, that's going to give us a nice result. And maybe that's why we have whole numbers for these results, over 2. If you wanted to, you could actually start to simplify this now, but you'd have to keep this over a half. But I think I'll save that for later. So this is going to be equal to 2 plus or minus the square root of 100, which is 10, over 2. Now, I don't think we need to do this in multiple steps, but 2 plus 10 would be 12. Over 2 would be 6. And then 2 minus 10 would be negative 8. Over 2 would be negative 4. So the old way of factoring it is way less work. And the new way of using the quadratic formula is way more work. And like I said, if you think, well, what's the point of it? Well, just remember that I'm choosing. What I was saying is you're going to have to use this for ones that don't work out nicely, where you can't choose to use factoring as a solution. So where these end up being a dead end, that's where you do this. So I'm choosing to use one with integers to help the concept make better sense. So they're not dealing with something with ugly square roots just yet. So having done this one with more straightforward results, hopefully that puts us in a spot to where we can do something that's a little bit less pretty. Okay, so just like the one before, let's do this one with factoring again. So here's 24x squared minus 14x equals 6. All of these are even numbers, and the better call would be to shorten up the amount of work you can do by dividing the entire equation by 2. I think that's okay to kind of shortcut there. Then you'd be realizing it's not enough to have something equal to 0. I'm sorry, equal to 3. You have to always have these set equal to 0. And so now we have a standard form version of a quadratic function. So we got 12, 7, and 3, which later on means that A is going to be 12, B would be negative 7, and then C would end up being negative 3. And that would work whether or not you use 24, negative 14, and negative 6, or these. It's just going to end up being a little bit larger numbers if you use something without having divided both sides by half. So here you'd be looking for the factors of negative 36 that add up to negative 7. And you can't come up with them because this is a dead end. So let's make a little note that this is a dead end. And it can't be done. So over here, one more time, we're going to rewrite the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And another friendly reminder, the reason you do this is that you want to be able to map the terms up, and then it's another time that you practice the values. So this time let's cut corners. Negative b would be negative 7, which is positive 7, plus or minus the square root of b squared, which would be 49, minus 4. And here I'm not really going to jump corners here because I want to be able to track this. A and then C. Only show this if you'd like to cut this corner, but otherwise go back. And then 2 times 12 is going to be 24. divide all of this out. Let's see what happens. 7 plus or minus the square root of 49 minus 4 times 3 is 12. 12 times 12 is 144. And a negative gives a positive. All over 24. 7 plus or minus the square root of 193 all over 24. So here, this really would be the end of the problem if we were told to be exact. So I could just be like, x is that, and box it. And you would always want to look at this and see, will this 7 simplify with 24? No. Is there a number out here that cancels or simplifies it all with 24? No. But since this said round to the nearest tenth earlier, if necessary, we're going to do that. So over here I'm going to write x is approximately, and we're going to have 2 values for that. And in red over here, I'm going to show you what you would type in your calculator. So here's 7 plus the square root of 193. But you wouldn't want to divide just that by 24. You'd have to divide the whole thing by 24. So you can go ahead and get it going like that. And then once you have the decimal approximation of that value, go back in your calculator and replace the plus sign with a minus, and then you'd get not just your first, but your second. Type those in and see if they agree with what I'm about to put up next for the values I got. Once I rounded those, I got negative 3/10 and 9/10. So as you saw, that's not really helpful with factoring. This is just a bit more challenging. I don't really know how I actually make this an OYO problem and see if you do well on it. And the same deal with the next one. So if you go to Wolfram Alpha, you can check and see if you plug these in and get the same decimal approximations. So in Wolfram Alpha, there's going to be the input bar. You'd put solve, blah, blah, blah. And then after you check it out, they're going to give you something with all the radicals involved. So it's going to be something plus or minus. So over in the corner, look and you'll see a button that says decimal approximation. So do these 2 OYO. And this will be the first of 2 videos for solving quadratic equations by using the quadratic formula.